So, welcome back student to the next class of complex analysis. So, we are almost at the end part. So, probably this is the last class we are having. So, today we will continue with the Cauchy's residue theorem, and we will now like to solve the problems having the form this that we mentioned in few early classes. So, this is a real integration where the limit is indefinite minus infinity to infinity. So, normally what we will do that we take the limit of these things. So, limit r tends to infinity, then minus r to r, and then whatever the function I have fz fx dx here, because I am dealing with the real integration. So, I will have this fx dx. So, limit r tends to infinity minus infinity to minus r to r. If this limit exists, then I can say the integral, whatever the integral value I1 say or I say is convergence. So, the limit is convergent if the limit is, I first calculate this integration with the finite limit minus r to r, and then put r tends to infinity. If this I has the limit at r tends to infinity, then we can say this integral is convergent. So, this is one important idea to do that. Now, I will going to tell how to deal with this kind of integration. So, if I now draw, if I draw the real and imaginary axis, this is real or x axis and this is imaginary or y axis. So, the integration is over this real axis, right. So, because it is minus infinity to infinity. So, the contour that we are going to choose is something like this, the blue line, So, this will be minus of r, this will be r, and I will take a half circle over that. So, I will go this, return back. So, this entire blue thing is nothing but a closed loop or closed circle, and all my singularities may be here. We may have singularities Z1, Z2, Z3 and so on, and I write this line as CR, right. So, this closed integration contain two part, one is this line which we call CR, and another is over the real line which is running from minus r to r, and if I add all these things I will have a closed loop. So, this integration first I need to write in terms of z. So, this integration minus infinity to infinity, I want to find this integration. So, what should be my consideration? So, first I will change this fz to fx to fz. First I change to complex integration. Then I will take the complex integration over this circle, whatever the circle I have, whatever the closed region I have, this is the half circle, and then I cut this from here to here. So, whatever the closed region I have, I call it C, in total it is C. Then this fz I calculate, this is nothing but the combination of two integration. One is the line integration CR, where my function fz will remain same, because I am taking the I am doing the calculation for all complex numbers here, all complex numbers or imaginary numbers. So, fz will be my function, but when I integrate the another part, so I go here from here to here, and then what happened, I go from here to this point to this point. So, I need to add minus r to r, right. So, what function I will write? My function will be simply fx here because the function is lying over the real axis having all y 0. So, since all y 0 there will be no y, only the x term is there. So, I will have the integration. So, there will be two integration. So, this two integration I write say I1 plus I2. After having the result, so what should be the result of this integration, that is known, that is nothing but 2 pi I, again I am using the Cauchy's residue theorem. So, Cauchy's residue theorem suggests that I need to just find out the residue of the function, whatever the function is given here f z at zk. How many residues are there, we need to find out k 1 2 say n, finite number of residue which are these points. Okay. So, that is the recipe to do this problem. So, let us do one example, then things may be clear. So, first I need to have a real integration with the limit minus infinity to infinity. Then what we will do, I change this fz fx to fz, my complex term, complex function. This then I integrate this complex function over this blue curve, closed curve, I call it C. It will be divided into two part, it is divided into two part. One is CR, which is this, where my z over C, my z is r e to the power of I theta. Theta is ranging from pi to 0, this is the range. And then I have another integration which is this line integration minus r to r, and the function is now I should not write f z because y is 0. So, I will write f x. So, my integration is this one, this is the desired integration I have. Why? Because the function is giving. So, next things I will calculate the integration at the limit r tends to infinity. This value I will calculate and then I put r tends to infinity and check how these things are diverging or converging, and that will be equal to this, and I will extract this I2 from there. So, I2 will be this minus I1. I1 I need to evolve at r tends to infinity. Okay. We understand these things. So, let us use this concept to find out some real integration whose limit is minus infinity to infinity problems. So, let us take one example or problems. So, okay. So, first problem I will have minus infinity to infinity, the function is given as x square minus 2x plus 2 dx. This is the integration I have in our hand. So, now I need to convert this integration as closed integral 1 divided by z square minus 2 z plus 2 d of z. This integration over real axis, since I will going to evolve these things over this region that I shown minus r to r, and this is CR, and this is my closed path, this is my closed path. So, this path is C. So, entire path is C. So, this is the integration. CR is only this from here to here, it is CR, this is not a closed path. So, this is the integration I need to evolve. So, now again this integration has some value. So, let me first find out what is the value, because I know very quickly what should be the value of this integration. The singularity I will find, and 2 pi r multiplied by the residue will give you the result. So, let us find out what result I am getting. So, z square minus 2z plus 2 equal to 0. So, this is, so if I write it z minus z1, z minus z2 equal to 0, then what should be my z1 and z2, I need to figure out. So, my z12 here is minus b, so it is 4 plus minus root over of b square, which is minus of 2 of square minus 4 AC, minus of 4 AC, 4 into A is 1, C is 2, so 4 AC divided by 2, right. So, it is how much? 4 plus minus of root over of 8 minus of 8 plus 4 by 2. So, it seems to be something like this will be minus of 4. So, minus of 4 means 2 root I. So, 2 of root over of minus 1. So, that means 2 I. So, I will have something like 2 plus minus of seems to be something like this. Let me check once again. Okay, so here it is not 4, minus b is minus 2. Why I am writing it as 4? It is minus 2. So, then it become plus 2. This is plus 2. This is plus 2. So, minus of b plus minus root over of b square, which is minus 2 square minus 4 AC. So, minus 4 into A into C. So, 1 and 2. So, minus these things. So, it is 4 and this is minus 8, this is 2. This will come out to be as 2 plus minus of 2 I divided by 2. So, I will have 2 point, one is 1 plus minus of I, that is all, 1 plus minus of I. So, my Z1 here is 1 plus I and my Z2 is 1 minus I, these two. So, now I check where the Z1 and Z2 point are in this particular case. So, I plus 1 is somewhere here, 1 plus I somewhere here, this. So, this is the point of my Z1, which is inside this region, mind it, and another point is a replica mirror image of this point, which is here Z2 and which is outside the region. This is just outside the region, not inside the region. So, that means this is inside, Z1 is inside, this point is inside and this point is outside. So, I know which point is inside and which point is outside. So, next is to find out the residue. So, the residue of this function, at Z1 point is, Z1 is inside, that is why Z1 point is limit Z tends to Z1, Z minus Z1 multiplied by the function is 1 divided that. So, it is Z minus Z1, Z minus Z2. So, Z1 cancel out, I will have this. So, when I put the limit, it will be Z1 minus Z2, 1 divided by Z1 minus Z2. So, Z1 minus Z2 is two of I, Z1 minus Z2 is 2 of I. So, the value of this integration, the value I have already figured out, the value of this integration. So, this residue is 1 divided by 2 I, the residue is 1 divided by 2 I. So, the value of integration, let me write it here, 2 pi I multiplied by 1 by 2 I. So, the integration seems to be only pi, the integration seems to be only pi. So, now this integration, let me erase this. Now, the next part we need to take care. So, this integration now containing two part. So, this I convert this, this is not equal to, please mind it, I convert this to close integral. So, this integration I write it function. So, this integration C, if I write this as a function of z dz is equal to I1 plus I2, which is equal to pi, right. So, what is I1? I1 is the integration of CR this function of z dz, and what is I2? I2 is integration minus infinity minus r to r, integration minus r to r function of z function of x dx. So, I need I2 here because I2 is my integration, and then I put r tends to infinity, that is the concept. So, let us find out what is this CR. So, integration CR, if I put this value here, it will be z square minus 2 of z plus 2 dz. The contour once again it is something like this, this is minus r, this is r. So, this point is my z point here. So, z is r e to the power of I theta. So, now if I convert that, then I say this is my I2, and now if I convert in terms of r over CR, I do that over CR. So, it will be dz will be r I e to the power of I theta. So, it will be r I e to the power of I theta d theta divided by this quantity. So, this is r square z square, which is r square e to the power of I 2 theta square minus of 2 of r e I theta and plus 2. So, now what I am not going to do the entire integration over that, but I am just looking what will be the form of the integration, how the integration will be look like when r tends to infinity. In order to do that, I can simplify one thing, that I take the mod side of both sides. So, if I take the mod of both sides, then it should be less than equal to the integration CR mod of this quantity divided by mod of that quantity r square e to the power of I 2 theta minus 2 of r of e to the power I theta plus 2. Now, as I mentioned, my aim here is to find out the integration when r tends to infinity. Now, if I try to find out what is happening here, r tends to infinity. So, limit r tends to infinity, this equation, this function, we have r in the denominator. So, 1 by r is a constant. So, it is not depends on theta. So, integration in the integration r is constant. So, if it is a constant and if I put this limit r tends to infinity, you will find that the denominator is changing with the order of r square. So, that means the right hand side r tends to infinity, this quantity integration CR, whatever the function I have, this it will going to be 0. So, right hand side which are mod. So, when I take mod, then this mod will be outside the integration. When I put the mod of inside, then this quantity obviously greater than this one, because summation of something, this is always greater than equal to this quantity. So, this is always greater. So, I am doing these things here. So, this when I put the mod of these things, I should put mod of these things here and here outside the integration. Now, I put this mod inside the integration, then this quantity should be greater than this I1. Okay. So, now at r tends to infinity, if this quantity goes to 0, then that means I have I2 is 0 also. I2 will be 0 with the condition limit r tends to infinity, that is my outcome, that is my outcome. So, once I have this, then this integration will become minus r to r limit r tends to infinity, this integration is become pi. So, now this is converging because right hand side I am pi. So, I can write this is called Cauchy's principal value. So, I can now write safely minus infinity to infinity 1 divided by x square minus 2 of x plus 2 dx is equal to pi. So, this is the result of the integration pi, but you should also take care of the issue that what will be the value of integration in CR. You need to check every time whether it is going to vanish or not. If it is going to vanish, then okay, otherwise you have a problem, but normally the problem is given in such a way that in all the cases you will find these things will going to vanish. Okay, quickly we will take another example where two functions are associated with that. So, let me check what example is in my hand right now. Okay. So, I have this integration. So, minus infinity to infinity e to the power, not e to the power, it is cos of x, now x square plus 1. This is the integration I need to evolve. So, here the integration is slightly different from the previous one, because in the previous integration everything was a function of x, but here find it is combination of a trigonometric function and the algebraic function. So, these two are there, but we shouldn't bother about that, because we need to convert this as a complex form. So, when I convert to a complex form, cos x will write at e to the power of I z divided by this quantity I will convert this and this quantity I will convert z square plus 1 dz. So, why I write this e to the power I z cos z. So, if I do e to the power of I, it will be x plus x plus I y, which is something like this. So, it will be e to the power of I x multiplied by e to the power of minus y, right. So, this quantity is e to the power of minus y multiplied by cos x plus I sin x. So, this is this integration, if I do, when I do this over real axis, this is the real axis, over real axis, then y is 0. When y is 0 over real axis, we have two component, one is cos x and another is I sin x. So, this if I write in this way, I should eventually have this expression when I am evaluating it over the real axis. Now, when the result, this is the real part, if I have a result which has a real and complex part, if I deal with only the real part, then the result will come for cos x. If we deal with the complex part, the result will come for this case. Once we have this and this together, then I can evaluate this quantity as well as this quantity. So, this is the general way to take whenever you find cos x or sin x, and then do the integration and find out whether this is a real value or the complex value, and then you will convert this accordingly. Let me do the problem, then things will be clear to you. So, I know this is my, so this same contour I am going to use minus r to r, because my limit is minus infinity to infinity, minus r to r is there. So, now if I try to find out what is the residue, it is z square plus 1 is equal to 0. So, that means z is z1 2 is plus minus I. So, one residue is at z1 is equal to I, another residue is z2 is equal to minus of I, right. So, that means one point is here, I is here and minus I is here. So, minus I is outside. So, the residue, what will be the value of this integration? The value of this integration is equal to 2 pi I, then summation, then residue of the function at I point. So, that means 2 pi I, what is the residue, what is the function? So, limit z tends to I e to the power of I z divided by z minus z2, z plus z2, where z, because z I have z1 plus z2, this I z1 z minus plus z2 equal to 0. So, that was the condition, my z1 is I and z1 is, one is I and another is minus I. So, if I put this here, then we have 2 pi I and z2 is I. So, it is e to the power of I into I divided by I plus I. So, it is 2 I. So, I will have pi e to the power of minus 1 2 I divided by 2 I. So, 2 I will cancel out. So, I will have pi by e. So, pi by e is the result, pi by e is the result. So, now you can see the integration of these things are pi by e, that means this is a real entirely real value. So, when it is a real value, obviously it should be related to this cos x. If I find the sin x, then the sin x integration is 0. So, the rest part is straightforward. Now, this integration has two parts as usual, one is I1 and another is I2, which is pi by e. This I1 part is integration of CR e to the power of I, z is r cos theta plus I sin theta divided by, now I am putting the value of z as r e to the power I theta. So, r e to the power I theta is r sin theta plus cos theta. So, I am writing this only. So, this is equal to z, and in the downstairs I just write z square. So, I write r square e to the power of 2 I theta plus 1 d theta, and when I put d theta, 1 r will be here with I and e to the power I theta. Now, if I put the limit here I1, again mod of these things will be less than equal to CR, limit of these things, mod of these things, the mod of these things is e to the power, one term will come out as r sin theta and r will be here and other term will going to vanish, d theta is also here when I took the mod, and the downstairs I have mod r square e to the power 2 I theta plus 1. Now, again we can check what happened of this integration when r tends to infinity. When r tends to infinity, this quantity will going to vanish, because e to the power minus r will decay very rapidly. On top of that, we have r square term here also. So, r square also tend the integration to put the integration towards 0 with the limit r tends to infinity. So, then I can write that under this condition r tends to infinity, limit r tends to infinity minus infinity to infinity cos of x square plus 1 dx is equal to pi by e. So, this is converging. So, now again I write this is minus r to r. So, minus infinity to infinity cos of x square plus 1 dx is pi by e, where I1 is tends to 0, that I show. So, students, I have shown almost all the different type of integration using the rule of Cauchy's residue theorem. So, that is the syllabus so far we have in our hand. So, almost all the problem I have covered. So, I believe you have enjoyed this course thoroughly, and I would like to give you a best luck of this course. Please carefully to read all these things, do all these things, and that is the thing. So, probably today is the last day of this class. So, I will give you all the best lucks. Thank you for your kind attention and taking this course. So thank you, and best of luck.